So good evening to and all. This is me Karthik from Konganadu College of Engineering and from the Department of Computer Science and Engineering. We are seeing about the fourth unit in cloud computing CS8791 in fourth year of seventh semester. So fourth unit, so resource management and security in cloud computing. So in fourth unit, we are going to see how the resources are being managed in cloud computing, and for that what uh, patterns or what techniques you are going to use, and resource provisioning and resource provisioning methods. All it is related to resources, how the resources are being managed in cloud computing, and global exchanges of cloud resources, security overview, and security related challenges and issues in second part of your fourth unit. How the security challenges, what are the security challenges are there, how the software is given as a service, security governance, virtual machine security, IAM, and security standards. So one of the important and difficult topic to understand is so global exchange of cloud resources. So it is the important topic in fourth unit, and it is difficult in it is important topic in cloud computing, and it is in resources also. When we need to have cloud computing, how the resources are being managed. So imagine that at a particular time, in this time, we cannot imagine that how many of you are accessing Google in worldwide now. So how these all resources are being managed in globally. So that is the important feature or important issue in cloud computing. So at the time, how many of, we cannot imagine that in worldwide how many of you are using Google. So we cannot how the resources are equally and distributed over all the users in globally. So that is the important feature in cloud computing. This has to be kept in mind while the development of cloud computing in at the starting stage. At starting stage, it is not a problem. At few number of users will be there, and few number of resources and few number of services will be there. So when it is keep on improving, we need some additional patterns, additional techniques. So in order to support a large number of applications, that is services consumers from around the world, cloud infrastructure provides IaaS services have established different data centers in multiple geographical locations to provide redundancy and ensure reliability in case of site failures, right? So example, at the starting stage in the development of internet, it is very limited number of users are there, and very few only have been used cloud computing, that is internet in 1990s. So after it is being well developed, we came into cloud computing, where we have started to store our data in remote applications in centralized data. So when cloud computing also keep on improving and number of users are getting increased day by day, how your search engines is or how the service providers are managing their data at different locations. So if you are accessing your data from one location, that same data will not be accessed from other location. So example, if you are accessing your data from India, the same people, they are accessing some other topic in Google. Imagine that at the same time, some other users are accessing your data from US. The same data will not be there. You are going to access Google for different purpose, and I'm going to access the Google for different purpose. If same topic has been searched at different locations, how the data is being distributed, right? So that is the data centers. So data centers, example, your Google, it is connected to all the go worldwide, it is get connected, that is globally it is connected, right? If in case it cannot be able to process the data from all the uh, clients over the world, if they maintain only one data center. So they have been maintained different data centers at different locations to solve their redundancy problem and ensure reliability in case of site failures. So redundancy in the sense, if any system will get failures in between, it has to be recover after some time. For example, Amazon has data center in the US, one on the east coast and another on the west coast and the Europe. It maintains different setas, it is at different locations. So currently Amazon experts its cloud consumers, that is customers, that is software service, to express a preference regarding where they want to steer their application services to be hosted. Amazon does not provide seamless automatic mechanisms for scaling its hosted services across multiple geographically distributed data centers. So example, this is your diagram of your example. So globally, how the data is get distributed. So here in the diagram, one lady is accessing its data from remote location, right? So this data is get globally shared, and how the information is gets stored from one environment to another environment. So we have storage cloud or one part, and compute cloud another part. Here we have enterprise IT consumers, that is enterprise proxy at one point. So we have different brokers in cloud computing. So we'll see what is a cloud broker, cloud service providers and all in the next few topics. So globally, how your data is being exchanged from one data centers to another data centers. So example, if one data center get fails, so the request will be processed to the nearby data centers, and cloud environment will accept that data as a request. And if what data you has been requested from the cloud service, cloud servers, that data will be processed from different locations. So example, if you are going to use Google as sometimes our location will be changed. So if we have any problem in nearby data centers in our location or in our country, the data will be forwarded to next nearby location, that is next nearby data centers, and that data will be get processed by that data center, and that data will be written back to the location, that is our user will retrieve that information at a response. So this is the reason where our data is globally get distributed, and our data is shared from one location to another location, and these data is transmitted or processed without any deviations, that is a redundancy in our concept in cloud computing. So redundancy and to ensure reliability in case of site failures. So if any site or any information is get failed in between, our data should not be our response or request should not be stopped in between. So nearby data centers or nearby locations or nearby country data centers will share that information from that location. So that is globally distributed. So imagine that if Google or Amazon has only one data center in their head office, and it is get distributed globally, only one data center will how it can be able to process different clients at from different locations. So sometimes, so this is the reason why Google is not get slowed down at any time. So at this time we cannot imagine that Google, how many of you using that, so it is not get slowed down at any time, because that resources has been shared globally, and different data centers is at different locations. So all this information is get processed at very short time. That response is get back from the consumers. So this approach has many shortings. First, it is difficult for the customers to determine in which advance the best location for hosting their services, as they may not know at the origin of customer of the service. So very first time, if I'm starting a business, I cannot be able to know that which is the best location for hosting my service, right? Sorry. And they may know the origin of consumers of their service. So it has different shortcomings. So one of the shortcoming is I cannot be able to know which is the best location for hosting my website if I'm starting the services at first time. The second, because the data centers will be at different locations. Second, the software service providers may not be able to meet quality of services expectations of their service consumers originating from different multiple locations, right? See how the software as a service is provided to be able to meet the quality of services expectations. So there are different quality of service parameters in the cloud computing, how the services are being satisfied their customers by their services. So in addition to that, no single cloud architecture will be able to establish it data centers at different possible locations throughout the world. So one single cloud structure will not be able to provide. So as a result, cloud services application service providers will have different meeting and quality of services expectations for all their customers. So all we cannot depend upon one cloud infrastructure providers and one application, and or they have to develop different data centers at all the possible locations throughout the world. So they are the major cloud service providers, right? So example, your Amazon and Google and IBM, they are the biggest achievers and biggest cloud service providers in the real world. So they maintain different data centers at different all the possible locations. So at the very first time, when the Google starts, it will have very limited number of data centers at only one place. So after developing, so now imagine that what's the biggest advantage of Google. So everybody are accessing Google. So if you want to search any data, you are going to Google and directly you are accessing Google at different places. So this kind of requirement often arise in the enterprises with global operations and applications such as internet services, media hosting, and web applications 2.0. This necessitates federation of cloud infrastructure service provides us for seamless providing of services across different cloud service providers. By realizing this architecture, principles and mechanism in their offering, cloud providers will be able to demi- demand dynamically expand or resize their provisioning capability, shut down on sudden spikes in overload demands by leasing available computational and storage capabilities from other cloud service providers. So that is the scalability. So when there is demand, it will expand their services, or if there is no services at particular time, it should be resized to the original positions. That is scalability. So example, if Google has been accessed a particular time, then this time by 1 lakh people, it has to be extend their resources. That is globally it has been distributed, and from different locations you are accessing that Google. All the data centers should be able to process that 1 million customers at particular time. After some time, if there is no customers, only 1,000 customers, all these data centers should be able to process this 1,000 customers, and they should resize your architecture. I cannot be able to, if I'm having 1 lakh data centers at different locations, I be able to process 1 million people and 1 million requests at different locations. At particular time, if I have only 1,000 request, all the data centers cannot be able to allocate. I will allocate only minimum number of data centers. I should be resize my capability. So when there is demand, I should expand. When there is no demand, I should resize your cloud architecture. So that is the principle of global services, which has been globally it is splitted. So being cloud exchange, the cloud exchange act as a market maker for bringing together cloud providers and consumers. So to bring your producers and consumers in services, the cloud exchange makes a dramatic interaction between your producers and consumers. This aggregate infrastructure demand from our applications brokers and evaluate them against the available supply currently published by the cloud coordinators. So all this take care by your cloud service providers in the in between. So cloud exchange allows participants to locate providers and consumers with fitting offers. Such markets enable services to be commoditized and thus will pave the way for creation of dynamic market infrastructure for trading based on service level agreements. So SLA, it is service level agreements between the cloud consumers and cloud providers. So to avoid any problem in cloud computing, so we have service level agreements between cloud providers and cloud consumers. So it aggregates the infrastructure demands from applications brokers and evaluates them against the available supply currently published by the cloud coordinators. So the architecture has to be able to process different number of demands and different number of consumers based on the supply chain management. So if that is more demand, it has to be increased. If there is no demand, it has to decrease. So these markets enable services to be compromised and thus will have the pay for creation of dynamic market infrastructure. So if there is any changes in the cloud environment or market, your cloud architecture has to be able to manage all these activities. So that is the importance of global sources, exchange of global exchanges of cloud resources, right? Thank you.